Welcome to the channel everyone. Myself Abhishek and today I will be discussing about ISA Activity 1, that is about air breathing engine and its inlet, with my colleague Harshal Thul. So basically, what is an air breathing engine? An air breathing engine is a type of propulsion system that draws in atmospheric air to combust fuel and generate thrust. These engines are commonly used in aircraft and rely on the oxygen in the air to sustain combustion, making them more efficient for operation within the Earth's atmosphere. So, to understand an air breathing engine properly, we should know what is the working principle behind it. So, the working principle of an air breathing engine is as follows. So, the first step in the working principle is to air intake. The engine pulls in atmospheric air, and the another step is compression. The air is compressed to increase pressure and temperature. Combustion fuel such as aviation kerosene is mixed with the compressed air and ignited, producing high temperature, high pressure gases. Exhaust. The expanding gases are expelled through a nozzle generating thrust on the application of Newton's third law of motion. So basically there are various types of air breathing engine, and these are the four main types of air breathing engine. So first type of air breathing engine is turbojet engine. So it is a basic jet engine that is efficient at high speed and commonly used in fighter jets and combat aircraft. The another type of air breathing engine is turbofan air breathing engine. It has a fan for additional thrust and better fuel efficiency, and it is generally used in commercial airlines. The next type of air breathing engine is ramjet. Ramjet operates at supersonic speed without moving parts, relies on high speed airflow for compression. The another type of air breathing engine is scramjet engine. So basically scramjet is a supersonic combustion ramjet engine that is similar to a ramjet but operates at hypersonic speed that is usually above Mach 5. Now we will be discussing about inlets. So what is an inlet? An inlet is a component of an aircraft engine, especially in air breathing engine, that directs the control of flow of air into the engine for efficient combustion and thrust generation. It is the first part of engine and plays a crucial role in ensuring smooth and consistent airflow under various flight conditions. So to understand an inlet properly, we should know what is the function of an inlet. So the function of inlet are as follows. Air capture. The first thing that inlet does is to capture the air. It collects and channels the atmospheric air into the engine. The another function of inlet is to airflow regulation. An inlet ensures a steady, controlled flow of air even during changes in speeds or altitude. And the another function of an air breathing inlet is the compression assistance. It also helps to increase the pressure of incoming air, especially in supersonic inlet. Shockwave management. Supersonic and hypersonic engine, it manages shockwave and compresses the air before combustion. Now we will be discussing about types of inlets. Subsonic inlets. Inlets are generally used for speeds that are below Mach 1. Subsonic inlets are generally simple and smooth designs with pitot inlet for efficient low speed airflow. Another type of inlet is supersonic inlet. These inlets are generally used for the speeds above Mach 1 and use converging diverging shapes or shockwaves to slow down and compress the air. Examples of supersonic inlets are normal shock inlet that is used for Mach 1 and Mach 2, and mixed compression inlet that is used for higher Mach speeds. The another type of inlet is hypersonic inlet that is generally used for Mach 5 and above the Mach ranges for it. It has a hypersonic inlets generally have a complex design like external compression ramps to manage extreme air pressure and temperature. Now, the further part will be discussed by my colleague Harshal Thul.
From here, I will be discussing about Lockheed SR-71 Blackbird. The Lockheed SR-71 Blackbird is a long-range advanced strategic reconnaissance aircraft developed by Lockheed Corporation Skunk Work Division. It is famous for being one of the fastest air-breathing aircraft ever built, capable of sustaining flight at Mach 3 over 3,540 km per hour. Case specification. Roles. Strategic Recognition Aircraft. Manufacturer. Lockheed Corporation Skunk Works Division. First flight. The Lockheed SR-71 Blackbird took his first flight at 22 December 1964. Retired. The Lockheed SR-71 Blackbird retired at 1998 by U.S. Air Force. Crew: Pilot and Reconnaissance System Officer. Maximum speed 3.3 Mach, which is up to 3,540 km. Service ceiling: this aircraft has reaches up to the 85,000 feet range, 5,400 km without refueling. Engines: 2 into Pratt Whitney J58 turbo ramjet with afterburner. SR-71 engines: Pratt Whitney J58 engine, a turbo ramjet hybrid. Engine type: turbojet engine with ramjet characteristics. Its J58 engine produces 32,500 pounds of thrust at a maximum speed using afterburners. How it works at a different speed. Subsonic speed below Mach. Operates as a traditional turbojet, compressing incoming air, mixing it with fuel, and igniting it to produce thrust. Supersonic speed Mach 1 to Mach 3.2. Shift into a ramjet-like model at this speed. Bypass airflow up to 80% of incoming air, bypass the turbojet core and directly feeds the afterburner. This design reduces stress on the core and increase efficiency. SR-71 engine inlet system. The SR-71 engine inlets were variable geometry and key to its supersonic performance. These inlets control how air enters the engine, ensuring optimal pressure and airflow at various speeds. First, primary component of an inlet system. Inlet spike. Conical spike, a sharp movable cone at the front of each engine inlet. Bypass doors. Adjustable vents around the engine that control airflows. Diffuser section. Slow and compress air before it reaches the engine. How the inlet works at a different speeds. First is subsonic flight below Mach 1. Inlet spike is fully forwarded, allows unrestricted airflow into the turbojet core. The second one is supersonic flight, which is up to Mach 1 to Mach 3.2. Inlet spike retracts up to 26 inches as the speed increase. This movement controls the position of the shock waves inside the inlets. Shock waves slows incoming air to subsonic speed before entering the turbojet. The third one is at Mach 3.2, which is the cruising speed. 80% of the thrust is generated by the compressed air flowing directly into the afterburner, which is ramjet mode. Only 20% of thrust comes from the turbojet itself. If the shock waves moves out of a position called unstart, the engine power abruptly causing violent yaw and potential instability. Now, from here we will be discussing about our group discussion.
So, hey Harshal, have you ever thought of how air-breathing engines take in air efficiently? The inlet plays a huge role in their performance.
Yeah, I know the inlet is important, but I'm not really exactly sure how it is works. Can you explain?
Sure, the inlet is the first component of an air-breathing engine. It captures the incoming air and directs it into the engine while slowing it down and increasing pressure. This pressure smooth airflow into the compressor or combustion chamber.
That makes sense, but I guess different engine must have different types of inlets, right?
Yes, exactly. Inlets vary depending on the speeds of the aircraft. For subsonic aircraft like commercial jet, simple pitot inlets or bell mouth inlets work just fine. They are designed to minimize drag and provide a steady flow of air.
But what about supersonic jets, like fighter planes? Their air is moving at such a high speed.
Good question. Supersonic aircraft need to slow down the air before it enters the engine. They use convergent divergent CD inlets or ramp inlets. This design creates shock waves that reduce the airspeed while increases pressure, which is essential for efficient combustion.
Oh, I see. And I suppose for hypersonic speeds, the challenges must be even greater.
Hypersonic aircraft like scramjet need mixed compression. These use both external and internal shock waves to handle extreme speeds. The goal is to compress the air just enough before it enters the combustion chamber without creating much drag.
So, in summary, subsonic inlets focus on smooth airflow. Supersonic inlets the air down using shock waves, and hypersonic inlets have to balance high speed compression with efficiency.
That's right, and the inlet design directly affects the efficiency, thrust, and overall performance of an air-breathing engine.
This is this was really interesting. Now I understand why inlets are such a critical part of an engine design.
So, thank you. Here we conclude our discussion.